Hey everyone, welcome back to Bugnojutsu, the channel where we master coding, conquer LeetCode, and embrace the grind one problem at a time. Today's challenge is a classic, one that blends both mathematics and programming beautifully. We're talking about none other than Pascal's triangle, and in this video, we're going to break it down, step by step. Given a number called number rows, we need to generate the first number rows of Pascal's triangle. Pascal's triangle is a triangular array of numbers where the first and last element in each row is always 1. Every inner element is the sum of the two numbers directly above it from the previous row. Our goal is to return the triangle in the form of a list of lists, where each inner list represents a row in the triangle. Let's take an example. Suppose the input is number rows equals 5. We start with the very first row, it's just 1. Next row, 2 ones, so 1, 1. Now the third row, we begin and end with 1. The middle number is the sum of the two ones from the previous row, which is 2. So we get 1, 2, 1. The fourth row starts and ends with 1 again. Then we take the sum of 1 and 2 is 3. The sum of 2 and 1 is 3. So the row becomes 1, 3, 3, 1. Finally, for the fifth row, we do the same. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. So the full fifth row becomes 1, 4, 6, 4, 1. To solve this problem efficiently, we begin by handling the base case. If the input is just one row, we immediately return the triangle with a single 1. Otherwise, we initialize the result with the first two rows, 1 and 1, 1. From there, we use a loop starting from the third row up to number rows. For each row, we look at the previous row. This is important, because every new row depends entirely on the values directly above it. We begin each new row with a 1, because every row in Pascal's triangle starts with 1. Then, for the elements in between, we loop through the previous row and add each pair of adjacent numbers to form the inner values of the current row. Once we've handled all the middle values, we finish off the row by appending another one at the end. This completed row is then added to our result. We repeat this process until we've built up all the rows specified by number rows. Let's talk about performance. The time complexity of this approach is n squared. That's because in order to generate all the rows, we end up creating a total of roughly n squared elements across all rows. The space complexity is also n squared, since we're storing each element of every row in our final result. This is about as optimal as it gets for generating the full triangle, because you simply can't do better than filling in all the values you need. There's a lot to appreciate in this problem. First, it teaches the value of breaking down a structure recursively, where each step depends on the previous. Second, it gives us a taste of dynamic programming. We're not recomputing any values unnecessarily, everything is built incrementally from what we already know. And finally, it's a reminder that many problems that look mathematical can be solved elegantly with basic iteration and smart list operations in code. So that wraps up our breakdown of Pascal's triangle. If you found this explanation helpful, don't forget to like, comment, and subscribe to Bugnojutsu. We're building a community of coders who push each other to the top. Got any suggestions or tricky LeetCode problems you want us to cover next? Drop them in the comments below. Until next time, keep grinding, keep growing, and as always, code like a ninja.